is this supposed to be, does this be the YouTube? Okay, cool. We're going to go again. Like I was saying earlier, I was protocol certain blockchain types. I know that like there was a web of various basically it's a build as you learn, or build as you grow blockchain, where like the core team would actually develop out transactions and transaction types for very specific applications. And I think like there was one example, or I'm not sure if it's still running. I don't think so, but at its height, it had like over 50 different transaction types, right? So each type, one would be for a binary option or bet on a binary option. One would be to make a prediction bet. Another one would be to settle the path bet, etc. But as you all may see, the like problem with that is every transaction type needs to be built out to accommodate one's creativity, right? So as more and more applications are built and then deemed to have some value, the amount of workload increases on the core team. So what did Ethereum do? Well, Ethereum is basically the smartphone to the Bitcoin calculator analogy. This is a blockchain version 2. And rather than define what type of applications are currently imaginable, kind of like keep that as like a very like white canvas and more or less a sandbox, and build a general purpose OS for those types of apps. The example is of course Ethereum. So now that the ice is broken, what is Ethereum? And fundamentally, it is a general purpose decentralized computer. And so that is basically some device or a collection of devices for storing and processing info, right? What types of applications run on Ethereum? Obviously, decentralized ones. We call them dApps. I missed a P there. I'm not sure if you all can see it. I missed a P, but and these dApps are called smart contracts. Any questions before we keep going? You all know all this stuff. I'm just kind of like laying out the basic fundamentals work. Hello. What's up, bro? That's my brother Royce. So we'll say hello after. Anyway, so I like to introduce Ethereum as the world computer. Now, what we see here is every block that you all see here is an object, and I'll go more into like the actual like structure of how Ethereum was built. But you have this world computer that is composed of all these square objects on the inside, and they can be interacted with other objects, but any interaction has to be initiated by some external account. Okay, so every external account is on the left side and has like a curved outer like contour to it, and the update to any object is through a means of a message or transaction. I just want to lay out the landscape before we dive in, but we'll come back to this image here. So, quick comparison. We have Bitcoin on the left, Ethereum on the right, and Bitcoin was one of the first, or it is the like first like blockchains out there. It's probably one of the most simple, as well as the most well tested. It has a simple stack-based language that's not Turing complete. Its type of architecture is UTXO, and it will likely keep proof of concept consensus in the coming years. Ethereum, on the other hand, yes.
Any acronyms like UTXO? What's
So that means unspent transactions. Well, what's the O mean, actually? I don't know that.
Unspent transaction operations.
Outputs.
Outputs. Okay, great. So what UTXO is like a type of our architecture that basically has everyone has like it's not like Ethereum is account based, but UTXO is basically a process of looking back at every transaction that has ever been committed on the Bitcoin blockchain, right? And if for any account that has access to an unspent transaction, right? So say that like I sent you like funds, right? I sent you like 100 Bitcoin, and you sent 10 Bitcoin to him. You still have 90 Bitcoin that have been unspent, right? So like a Bitcoin client or Bitcoin front end would look at all of your unspent transactions. And I don't want to go too deep, but when you send him that transaction, you also have to like specify where the other 90 goes. And so you just, if you don't send it to him, then it's just unspent.
That makes sense when you look at it in Explorer. Sometimes I think you see what you're talking about, where you specify a certain amount that goes out and then the other part goes back in.
Correct. Again, it's like not in actually,
Yeah, it's just you're not
because it's
putting
not
on.
into anything, it's just out like it's a ended like tail. Does anyone have any other comments actually? Pardon?
Turing complete.
Yeah, that's also,
Yeah. So Turing complete means that you can essentially write any like program that can, for the most part, like solve any imaginable computation. Okay. Does that make sense? And so that includes like looping. That includes specific like if-then logic. Any type of like contract, any type of variable storage, etc. So Ethereum is complex, and I'm not sure if it's robust enough yet. Currently it is, but obviously it's not as robust as Bitcoin. It is account based, so that like means that, or I should have said actually that it's object-oriented based. And the distillation of that is that all these objects are called accounts. But we'll go more into accounts. It has a Turing complete scripting language. Its native currency is Ether, and it currently has proof of work. Proof of work with plans to upgrade to POS. I'm currently not sure if you all follow proof on the current news, but we currently have a block reward of 3 Ether per block, but given this upcoming hard fork, we'll have one of 2. So again, back to Daniel's point. The difference between UTXO and accounts are the following. You all have just heard what UTXOs are. Basically, Bob owns the private keys to these set of UTXOs, and the front end or Bitcoin client and the wallet or front end that you are interacting with is able to distill how much Bitcoin Bob owns, even though that he's been sent it from various points. On the other hand, if Ethereum is object-oriented based, which means that Evan, for instance, would just own the private keys to this account, and this account has like a certain amount of like storage, and within that storage, it has a certain amount of like rows, right? One row is balance, one row is address, one row is coda, and the other row, which is not displayed here, is storage. We will go into that, of course, but the available balance is just what's shown in the balance state. So account types, we have externally owned and contract accounts. Externally owned accounts can be owned by anyone that's external to the system, whether that be a person, corporation, etc. Contract accounts are actual like pieces of code that also contains the 4 pieces of data also contained in the externally owned account. So contract accounts can be interacted with also by other external accounts as well as other contract accounts. It's important to note that the last 2 items, the last 2 pieces of data for under the account object is basically like nothing for the externally owned account. Yeah. Any questions? I'm going too slow, just tell me, and I can just take it up a notch. Okay, so the state of the Ethereum network is essentially a state of all of these accounts. Again, every object is some account, and every account has some set of data under it. So if you look at every account all at once, at one instance, you could be confident what the state of the Ethereum network is at that instant. How to update the state? That's through the use of transactions. Only externally owned accounts can initiate transactions, but once the transaction is within the blockchain, if it's for instance to like a contract account, then that contract can make other calls to other accounts, thus having like almost like a web of state updates within the blockchain. If it was only from one transaction. Again, just like they have it in Bitcoin, every transaction is sent to the mempool, and miners decide which transactions to bundle into the next block. And like transactions that approach finality of the system, they have to pass by several like blocks. They have to be put into a block and then accepted by the system several blocks after that. And so again, every node, every miner has to agree upon this new network state. Accounts can interact with the network, other accounts, etc., through these transactions. So again, transactions are submitted and initiated by externally owned accounts. Every transaction specifies a to address, and if this to addresses to a different externally owned account, then you're just going to be sending around Ethereum, right? So it's like any other like cryptocurrency out there, and there's not much use that can be captured. If you're just sending to other EOAs, but if you send it to a contract account, then code can be run. This should say run here. And so what happens actually is that you could, or like a whole like host of things that could happen. One is that you just send Ether to this. Another is that you read or write storage of this new contract account. And then, of course, this contract account can call other contract accounts. Now back to this overview. Again, you have all these objects, all of these externally owned accounts, all of these contract accounts that are interacting with each other, as well as being interacted with from these external accounts. Updates are in the form of transactions, and these transactions are bundled into blocks and then mined every 15, 20 seconds, etc. Any questions? But when a transaction is sent to the contract account, how does the code actually run? And that happens through the Ethereum virtual machine. Basically, this is a virtual machine that runs code. Contract code actually gets executed here. And if you look into the Ethereum client, the way that, like, I'm gonna do a quick aside, the way that Ethereum was set up, it was that there was the white paper release, but shortly after that, there was the yellow paper. And what that is the technical spec or specification of the Ethereum client. And so Bitcoin, on the other hand, released a white paper and then a client itself. And so now new clients that wish to operate and be interoperable with the system itself, or with the like Bitcoin network can like follow the Bitcoin client example, whereas Ethereum has, again, this like client spec. And so basically the EVM is just a set of standards. It's a set of protocols that defines how code should be executed. Okay, so EVM runs on every node, and every node can like have their own like client, or any node can have their own client that they run. If the EVM code is a low-level stack-based bytecode language, so that is composed of like opcodes that are stacked on each other, which is in accordance with the order of operation. These opcodes are very they're the most basic functions of the Ethereum blockchain. It's adding, subtracting, sending, accepting, etc. So I think that this may not be as valuable to us now because we are not protocol designers, but if you were curious, we have simplicity, space efficiency, determinism, specialization, and secure rating. I actually am not as familiar with all of the pros and cons of each one, so I'm going to go to the next slide. So basically, when you have, like as a smart contract developer, you don't need to, or here, I'll take a step back. On the left side is the actual data, okay? It's the smart contract. It's a piece of code that runs on the Ethereum blockchain. We don't need to know how to code an EVM code to create dApps. We could if we wanted to, but it would be extremely arduous. And so there are a handful of Turing complete high-level programming languages out there that programmers could use to abstract away all of the complexity here. So for two of those are the Solidity language as well as the Serpent language. Personally, I've only dealt with Solidity, so I'm not sure what Serpent has to offer over thereof. But anyway, when you write smart contract code, you push that through the programming language or the respective compiler. And what that compiler does is it compiles down your code into bytecode. And then that bytecode is sent to the blockchain in the form of a transaction that can then run on the EVM. Now, any questions before we go on? I'm kind of flying through this. It couldn't have been too straightforward, actually. Yes?
So these all, the Solidity contract, Serpent contract, and both the Solidity and Serpent compiler, are they like all the ingredients for making the EVM code?
Kind of. These are, so the compilers, it's really just like a tool to help the EVM read opcodes from the compiled Solidity code, right? So the EVM can only read, like it can only read a certain type of code, and that's called bytecode. So it has to, any code that is given to it has to be in that bytecode form. And so every smart contract development language has their respective compiler that basically converts the lines of code that you and I can read and converts that into bytecode. Okay, so what's the problem with this code here?
It loops forever.
Loops forever. Okay, great. No, that is not great actually. What if a contract has an infinite loop? Again, every node has to run this code in order to verify it in the next block. And so if every node is stuck in this infinite loop, how do you do two stuff? This is called the halting problem. So in computational theory or computer theory, there is this problem where there's no such algorithm that someone can create to determine if some code or some program will go on for an infinite loop or not, when only given the function name and the arguments used to run that function. Okay, and so if you have a bunch of people that are trying to bloat the blockchain, they would quite logically just spam the network with useless info. So to solve that, there is a concept called gas. And so every contract requires some amount of gas or some amount of fuel to execute contract code. Again, even on the EVM layer, every opcode has their own gas requirement. And so when a EOA specifies or starts to create a transaction, they specify two things. One is the max gas, which it may still be called stored gas, but it's the maximum amount of gas that someone is able to pay. That the externally owned address is willing to pay for that specific transaction. Gas price is basically the conversion rate from Ethereum to gas for that specific transaction. Gas price is it's an important note that gas and Ethereum are two different things, or I'm sorry, gas and Ether are two different things. Gas is an additional token that is basically created and then used at the time of contract execution. Did you have a question?
Yeah. What determines the gas price?
The market. So most in a perfect world, most wallet providers and clients are aware of the transaction mempool, and the mempool is a cloud of transactions that have not been locked in with the current blockchain yet. They are awaiting to be executed in the next block update. And so you have clients and front ends that are looking at this mempool and then comparing that to the average transaction fee, aka average gas price that was in the last block. And so based on the supply and demand of transaction execution, that determines what gas price will give you a payment time, right? So yeah. Good.
So if I spam the network with a high number of transactions that are paying high gas price fees for the, can I effectively create a denial of service on the entire network to prevent anyone from pushing blocks through?
Yes. Yeah. Yeah, but it would cost cash, right? And that's actually what the next slide goes into after that.
For gas, I just looked up now. With Ethereum, one gas is worth 20 GWEI, which 1 GWEI is 10 to the 9th. It's 1 times 10 to the negative 9 Ethereum. So it's kind of like, I think it's supposed to use 10 to the negative 9, right? I think it's like that. Like, hold on a second.
Satoshi, I'm not sure, but weighs to the minus 18 one way.
Oh, yeah.
And so gig away is to the minus 9, yeah.
Yeah, gigabyte. So, and then you can basically determine either the wallet, like what you were saying, either the wallet, or you can manually say like the units of gas to allocate the transaction. And then a lot of times what would happen is, for instance, like if a lot of people, the whole scaling issue, so like when, I don't know if you guys heard about crypto kitties, that kind of
Yeah.
So crypto kitties like kind of span the network with a lot of large volume transactions, and it caused like the overall gas price to go up by a lot. I think it was like, I don't know the data statistics, but it got to the point where that automatic pricing of gas on the wallet, people weren't able to send Ether because the range that it automatically chooses from didn't include how much gas you had to pay to get sent to go through. So I think at one point, sitting in Ethereum, someone was like, the maximum bill was like $2 of gas, but you had to spend like $6 of gas just to get a transaction to go through.
Yeah. That's a good point, actually. You aren't required to like set a gas price, right? It's just based on like how soon you want your transaction to be included in the next block. So, like Daniel was saying, in times of network congestion, if you need your payment sent ASAP, you are going to have to like pay the price of there being high social demand for that same blockchain. And again, it follows a same like incentive structure as Bitcoin. Miners have a limited block size to fill with transactions, and so they are going to look at the mempool and pull out the transactions to add to the block that equate to the highest revenue for them. The same thing applies here. Oh, and here is actually just an ETH gas station that constantly looks at the mempool as well as like previous or like average gas price in blocks. So we can see here that this is a confirmation time by gas price, 2 being 2 gig away per unit of gas. And then we have transaction count by gas price.
So what's the average? Is that the dial on the upper right? Is that the current average? No,
So
it's real-time gas use.
This is last block limit. I don't know what this is. I never actually look at.
Oh, it's below the 2.5. Like, what's the average right now? Average gas price?
Safe flow. Again, it's I'm actually not sure. Not sure. I always look to right here.
Okay.
So based
Right,
off
how many gas price?
based off of the current network conditions, we could like specify like a desired wait time for our transaction.
So is it something like price for Uber? It's defined by supply and demand of riders and drivers,
Exactly.
but then you can pay extra to get your car faster.
Exactly.
But what is that? Yeah, sorry, someone else go.
We've got
So is the 2.5, what is that in terms of dollars?
So it depends on how large of a transaction you wish to submit. If it is just sending money, if it's just sending the most basic like opcode is to just send Ether, right? And that requires 21,000 gas. And so if you change, what? Okay, they used to be able to like ship that, but I could do it real quick now. It's 21,000 times 0.001. It's 2, or say 2 to the
What's a gigawatt? Is that
minus 9.
10 to the 9? Or more than that?
It's in Ether. And then price, if we assume an Ethereum price of 140, that's 0.5 cents. 0.5 cents to send a transaction. I'm sorry, to just send Ether.
Can you explain the components of your calculation?
Yeah. So the first is the unit of gas to send another externally owned account that has some Ether in it, some more Ether. This is the amount of the gas price in units of Ether.
Mhm.
And then the final one is the conversion from units of Ether to units of dollars. This is like the all the price. Yes.
So there's a fee to send one Ethereum to another person? I didn't think there was a fee to to send one Ethereum.
There's a fee for any interaction with the Ethereum blockchain. There is a fee.
It's based on the amount of information, right, the amount of bytes that the transaction requires.
Kind of, yeah. So I think you're specifying to like there are like opcodes and each opcode has their own like gas requirement, and then there is one opcode that is related to storage, and if you request to store more bytecode, and then that scales with the amount of required fee or gas.
What does opcode stand for?
Operation code. Yes.
So if, what Daniel was saying about, this is Daniel,
Yeah,
right?
and
Daniel was saying about the CryptoKitties where they're making large transactions. Is that, are they doing that on the basis to make the amount of your gas price to send to Ether higher so that it would be harder to send Ether because they want to limit the amount of Ether spent, or what is the exact reason that they would want to increase the gas price?
So CryptoKitties was just another decentralized application that had a lot of demand for it.
It's kind of a game.
yeah,
So-
each cat, I still own some CryptoKitties from,
Oh, really?
but yeah, it was pretty crazy. I was flipping them.
Yeah.
Me and my buddies all got drunk with it over the weekend. But it's like each cat is actually a smart contract. So when you're trading kitties, you're actually you're using this something called MetaMask, which is actually a plugin that works with your browser, and you're like running a wallet on your browser, and you're actually that wallet is actually communicating with the smart contracts, which are the kitties, and then when you reallocate like a lot of their attributes and stuff, like because you can breed the cats, and, make new cats. That's how you can make a lot of money. You can get two good parents, and you can breed them and sell the cats, sell the kids on the market. But so the smart contracts will interact with each other. So to breed the cats costs gas. To sell a cat costs gas.
Yeah, really, it's just a byproduct of a system that is not ready to scale.
That's it. It's just there's only one game. And I have on here on the etherscan.io, if you look at the spikes, there's two spikes right here. This is gas price. Around the 2018, January 2018 time. But right before that, you see a spike beforehand. And that's actually, I think correlates, I don't know when CryptoKitties was released, but it looked like it almost doubled or tripled once CryptoKitties hit the market. Of the demand. So,
When was that?
right before, I think it came out like, late November, early December, so 2017. So you see how it went from like, no, that was when the bubble, but like the first peak was more when, yeah, that one. So like this early December is when it ramped up to the 50s somewhere. So I don't know what kind of magnitude that is. It looks like almost 4x of an increase on gas price.
I wish that this was normalized graph to show us it at least in US dollars.
Yeah.
You know?
Yeah.
It's very, very cool. Average gas price. Here it is. We can ignore that. But
Yeah, if you click and drag over a certain area, it'll zoom in on it. Yeah, there you go.
So I'm not sure if you all were involved with the space run this time right here. But the first like 2 weeks of January was pretty hectic with regards to like altcoins and like everything. Yeah, everything was just like going up, and like every like hour you would check your phone and see that you just like made like 20% or something. It was pretty wild, but that all came crashing down.
Specifically, some really small altcoins that didn't have heavy wallet support, not very like, for instance, there was one coin called Tron that went up exponentially, and then there was like selling for pennies before that. So then things like Sia coin went up in value, and then there was a few exchange servers where in exchange servers they have the wallets on their server, and they couldn't support the amount of Sia volume because Sia also went up, and they actually lost the funds. So me and a lot of other people, I think they lost that day like $500 million of the Sia coin at the current market value. And then they finally went through their servers and extracted everyone's Sia coin months later, but then it wasn't worth anything. So, yeah, so that can happen too.
Yeah. I guess the moral of that story is don't let your blockchain get too hyped before it can scale. So again, you have this max gas price or gas variable that is multiplied by the gas price. And at the start of the transaction, that is subtracted from the sender's account. So if you're ever trying to like send Ether from an externally owned account, and you have one Ether and you wish to send one, the transaction will not go through because you need that extra to pay for the fee in addition to your one Ether. So that's just a rookie mistake that we all like go through. So remember to always have some like a bit left over to use to actually pay for this fuel. So if the contract or if the operation of sending funds from one EOA to another was successful, then everything's great, everyone's happy, etc. But if the contract execution runs out of gas before it finishes, either within a loop or if your max gas was just too less, then the execution reverts and that gas is not refunded to you after. Okay, and what that does is it basically acts as an incentive away from doing a ton of service attack. If someone wants to spam the blockchain, they have to do it with money. They have to like lose value if they wish to spend. I like to think that it's that this gas is like a distributed, trustless, computational power unit, right? Like gas again is what fuels the Ethereum blockchain. Yes.
One possible attack vector, given that Ethereum is moving to a proof of stake system, is that if you have a lot of Ethereum, just holding a lot of Ethereum generates new Ethereum, which serves as a kind of a constant revenue stream that could be converted to gas that you could use as a denial of service attack on the network.
Yeah, that actually
That's part of why.
opens into a different type of attack two called a civil attack or something. I'm not sure if you're familiar, but it's basically along the lines of that the rich get richer as they stake their coin. But
Yeah, there's two things. One, since I didn't know this until a long time after I started mining it, but Ethereum actually had a pre-mine sale in the beginning, like when it was founded. So just by the nature of it, luckily, like people like Joe Lubin, put a lot of his money into the project. So people like him own a lot of Ethereum, but there are also a lot of people who are wealthy who bought into it when it was 30 cents a token, and yeah, they do own a large portion, but so I guess for the gas spamming, you could potentially use, it might not be enough to like cause disruptive amount if you're going off the staking rewards, but in terms of like when you're staking, when it goes through a stake, the main reason it's been delayed for so long is because of the whole game theory behind it in terms of where people with a lot of Ethereum can't, rewrite the blockchain because they're not gonna have miners doing that anymore. So it's a big game theory situation.
there is also another like ways to like additional lines of defense. One being that there is a chance of enough social coordination to basically fork, to basically determine the, well, actually, scratch that, because someone can just create new external accounts and use those like shadow accounts to like attack the net. So it couldn't be that like a hard fork would solve everything. What could be like a deterrent against that attack is that the price drops of that asset as the network is being expanded, and so any amount of like asset reserves that this hodler has been putting up a stake, it would go down in value. Yes.
I would think that there's some point at which, with a high enough investment, you could purchase enough Ethereum that would then be regenerated through proof of stake to like create a sustained denial of service on the Ethereum network, and that has a certain cost.
Yeah.
And so then it's a question of, are there entities that exist that have the capacity to leverage that much like financial power, right? Certainly, maybe governments.
Yeah.
Right.
It probably is, but it's possible to short Ethereum stock, right?
If you look at the Ethereum like asset price with respect to USD, yes.
So someone could
Just short it. Like
short it
buy
and then create a denial of service.
That's true, actually. Yeah. That is true. Yeah. So I take that back. And then also, I agree on both points. Like obviously, any government can just burn $1 billion to shut all of us up. They
They
do.
don't work for the time.
They do it?
They don't work.
Yeah, but like, if it's a large enough attack, they may like scare off anything that's less than like lean, mean, and really into this space.
Yeah, there's a website if you want, well, it's pretty short, it's called cryptos51.app, and basically it'll show you like the market value and 1% attack on every network based on the NiceHash rental rate, because you can run miners through NiceHash. So like, for instance, attacking a Bitcoin network for now only costs a quarter of $1 million of, without having running on farm. So the government could, for instance, using gas, spamming a network with gas has a zero net return, right? Whereas 51% attacking something does have a net return. And it also still disincentivizes people as well from using the network.
What was it again?
www.crypto51.app.
Yeah, no, it's certainly like a scary thing to even like think about. Because if this, like obviously, if you can rent enough mining equipment, you won't have to go through the hassle nor like capital expense to go out and like buy this equipment that would then become worthless after some time.
But it'll be interesting to break down the math and see how much the government has to spend for an annual subscription to, Ethereum transactions in the world.
Yeah.
So I feel like it might be kind of expensive, but it is a possibility until you break down the math. For sure.
Right, actually.
Yeah, I think the main thing too is, if the government's wanting to do that, or if some government, not the government, but any organization is trying to do that, then you can end up having, that's probably because people are going to be using it. It's going to probably have a higher usage rate than we have now. So it might just get to the point where they are just going to block out small transactions, like I can't buy soda or something. But if people still want to have it as like a store of value, they just have to have a higher fence jump over. It's kind of like the whole immigration thing when, you can make a wall taller, but it just means you're going to get higher ladders,
Yeah.
So.
Yeah.
It's not, well, it sucks because it's not like there's no hard amount of gas that would keep anyone from transacting basically. So your spending would have to multiply proportional to the gas price. So.
Interesting. Any other questions? Comments? Okay. Final thoughts. I think that final thoughts will be on the EVM. I can actually hold the smart contracts until next time. But final thoughts is that Ethereum is not, again, optimized to be efficient with regards to computation. The developers are attempting for it to be optimized to reach decentralized consensus. Because ultimately what this is a global, like singleton state machine that has integrated value in it. And so there has to be an adequate amount of consensus that is decentralized, that has a good balance of governance, coordination, etc. And so I think that, or not I think, but this is just what it is. And so, if it creates an incentive not to run raw computation on the network, and the aforementioned like gas mechanism is like the main line of defense against them. Yes.
I wonder with the attacks, since they would have to have multiple different types of accounts or, create these sort of like shadow accounts. Like PayPal had an issue while they were doing this marketing thing where they gave people money for referring new people.
Yeah,
And
I heard about that.
yeah, so people would create fake accounts and sign up fake accounts and get the money. But then what they ended up doing was they would go through and recognize patterns in people doing that and sort of the patterns of the accounts being created and of the transactions going on. And they'd be able to kind of figure out which ones are mostly fake from that. I wonder if they could do something similar for the blockchain network.
Yeah, there's a lot of stuff like that, more than beyond just kind of like finding shadow accounts. Like specifically, you're able to figure out. It just takes a lot of resources, pretty much.
Yeah.
But you can do it, and you can. Besides, like with currencies like Monero, for instance, it gets a little more challenging. But there's like Bitcoin or something.
With regards to like any like decentralized network, there would need to be probably like an upgrade to the protocol layer, as well as like a socialized acceptance that this is the new update, right? That like everyone would have to agree that baked into the code, this will like still offer a good balance of accessibility and it being permissionless, but also still have like a permissioned kind of like police nature to it that may be disaligned with some of the narratives that some of us have. So I'm not sure.
So as far as I understood, Ethereum is a kind of a smart machine. So why calculator costs more than smart Bitcoin?
Cost more.
Yeah, so you
market
compare
value.
Bitcoin to calculator
yeah,
and
yeah.
Ethereum to smartphone.
So-
So why does calculator cost more?
I'm sure everyone here can give their own answer to it. It's a complex answer, but and it's due to many things. My answer is that I think that it has the most confidence. It has the most net confidence of any other crypto asset in that space, and thus it has had more time to prove itself as a suitable store of value, as well as prove itself as a secure payment platform.
Isn't it because Bitcoin has a larger network, so they're more secure,
Yeah.
but Ethereum just has more applications? So, you know, a better analogy may be that like Bitcoin is a really high price calculator, whereas this is like an Android phone. You know, it just has a lot of applications.
Oh yeah, no. I was showing that just to like emphasize that.
Well, also, it's better to look at, if you're looking at the price of a unit, it's better to look at the market cap of the currency as a whole, because of the supply differences too. But even then, it's not, Bitcoin's still higher. At one point, I think in May 2017, it almost was a higher market cap than Bitcoin, but not quite.
The ETH flipping
Yeah,
it was
just
almost there.
yeah.
Yeah, so it was actually just a way to like kind of show what was the impetus to the release of Ethereum.
I have a question to that topic. So,
Yeah.
Are there any improvements, significant improvements done to Bitcoin blockchain protocol? I mean, like development improvements?
You know, not that I know of, but I'm also not that type of guy that you should ask. Like I'm sure there are.
Well, I mean, I was just gonna say, like, there's layer 2 solutions, but I don't know if you would consider those part of Bitcoin's, you know.
I know that like there was about 2 years ago, or almost 2 years ago, there was something called SegWit, and that was, and it stands for segregated witness, and it was a way of reorganizing the block data structure to basically be more efficient with how it bundles blocks. So that they were able to increase the block size of it. In addition to increasing the block size, it was a more efficient data structure to it, which increases throughput. But like Rob probably was saying, like the main improvement points that have been spoken about most recently have been with regards to the Lightning network, which is just a layer 2 routing like network of users. And so it's like if you and I do transactions, if we like are involved with transactions between ourselves, and we do it several times a week, rather than submitting Bitcoin blockchain transactions every time, you and I can enter into a smart contract or something similar to it that basically opens up a payment channel between you and I, And at the end of every week, we can submit the net value transfer into the Bitcoin blockchain, while still having the ability to fall back. Like if any one of us feels that we can't trust the other, there's like a period where we can basically revert any like proposed transactions of that channel.
So basically it's like a buffer.
A buffer of throughput, yes. It's kind of like a bundle of two. Bundle of two. Yes.
Just one more, kind of finishing up what you said about Segwit. I mean, they're still trying to implement that. Like, it's still, part of the development process. So the fact that Ethereum is able to implement changes so much more quickly and efficiently is like the analogy where the bigger ship takes longer to turn.
Yeah.
It's harder to turn or something like that.
Yeah.
So Bitcoin is much more decentralized, but that kind of has its goods and its bads when you're trying to implement and make progress and changes.
Yeah, agreed. Personally, I've been most interested by the Ethereum blockchain because of its community of developers, and like how vibrant the community is, and how I'm like sure to as well that there are other blockchains out there that have similar communities. But at least from a developer point of view, I think Ethereum has the strongest developer community out there in the crypto space, in terms of number of heads on it, not in terms of number of like sheer raw mental power, right? Because I'm sure I think Bitcoin has like some like Goliaths out there, right? Where they're like cryptography experts in CS, experts in engineering, psych, etc.
Ethereum is just so much more versatile as an initial program, though. Not necessarily the talent within, but like the possibilities of growth opportunities from people contributing their talents to it. So you reach from a much more diverse base, although you're not necessarily attracting the top of their field.
Yeah.
If those people are going to Bitcoin.
Yeah, exactly. So that's really, I'll just wait to actually hold the bid on smart contracts until the next talk. And then by then we'll be able to work with some of my code and stuff. But thanks for coming out.
You didn't even get into decentralized finance.
I know, I like,
Well,
actually, I like